So in addition to our three main climate profiles of temperate, tropical, and dry land, which every area on Earth fits into one of these three categories, we can also have a bunch of secondary effects, also known as orographic effects, that we need to take into account to establish truly which climate we're actually in. And these secondary effects are altitude, maritime effects, continental effects, rain shadows, and microclimates. So to give you an example here of how altitude would affect our climate, for every 100 meters that you go up in elevation, it's equivalent to being 1 degree latitude further from the equator. So to give you an example, if we were situated at 50 degrees latitude and we were at sea level, and then we decided to climb a mountain that was nearby, and we went 1,000 meters up on that mountain, that would be the equivalent of 10 degrees further from the equator, so 60 degrees latitude is how that climate would behave 1,000 meters up on the side of the mountain. In the same respect, so if you go 100 meters down in elevation, then that's the equivalent of being 1 degree latitude closer to the equator as well. So in Regina, Saskatchewan, we are sitting at 50 degrees latitude, give or take, and we are at 500 meters above sea level. So if I was trying to find some other area that was very close to ours, but maybe it was only at 200 meters above sea level, then I would want to try and adjust the latitude accordingly to try and find something that would match my climate accordingly. So we have to keep in mind, though, with this altitude change, although the climate effects are slightly different, the daylight does not change. So the sun angle does not change. We have to keep that into account. So it might not seem like it's going to be the same as an area that is at a different altitude than us, but that is the case. And the lowest that we can go here on Earth, when we're going down that every 100 meters towards sea level and everything like that, is actually 400 meters below sea level. So in Jordan, that is the lowest place on Earth where the land is actually 400 meters below sea level. If we look at something, a kind of a better example of how altitude really plays a factor here, if we look at Mount Cayambe in Ecuador, it's on the equator, but it's always covered in snow. It's at an elevation of 5,790 meters. Therefore, it's the equivalent of being 57.9 degrees away from the equator. And that's kind of hard to wrap your mind around in climate, but that is the way that it is. So in that situation in Ecuador on this mountain, he would still have 12 hours of daylight, 12 hours of darkness, but it would be behaving like a climate that is 57.9 degrees away from the equator, in the sense that you have snow and it would be cold. And as you come down the mountain, it's almost like you are going in the temperate region. It's almost like you're going through some of those sublevels of the temperate and tropical climates. So as you're coming down, you kind of get to a cold temperate type of zone on the mountain. And then you get to a cool temperate and a warm temperate and a hot temperate perhaps. You get to the tropical zones where you're getting to a subtropical kind of feel, and so on and so forth, until basically when you reach the base of the mountain and you're at the equator, you are at that equatorial tropical zone at that point. So all the way up the mountain, you're seeing really different climate zones in which you can grow different types of food. So you could see Mediterranean type crops, you can see cold climate type of crops. The only difference in how those things are grown is that you don't have the same length of daylight as you would have in a cold temperate climate when you're at the equator but way up high. So you might find apple trees which can grow there, but they won't bear fruit because there isn't a long enough daylight span like there would be if you were actually at 57 degrees latitude, for example. Another way to... There's two different ways that you could get fruit off of that apple tree too. So on its own, that tree will not produce fruit because it doesn't have a long enough daylight cycle. You can actually pick off some of the leaves and then the apple tree will flower and potentially produce fruit. If you spray them with a defoliant, then they'll also flower because essentially, again, you're removing the leaves. Don't ask me how that works, but apparently it works. So we can try and grow some of these things in really strange places. Like you wouldn't think of apples as being a tropical kind of plant. And when we grow things in strange places, then their value increases astronomically because those items are really, really scarce there. So, for example, you may end up paying $30 for an apple in the tropics, but you have amazing things that are readily available, like citrus and avocados and mangoes and durian fruit and all sorts of different things. We always want something that we can't have. In Canada, everybody wants to eat bananas all the time. We can't grow bananas. We can in some greenhouse situations, but it's not really all that easy of an endeavor, that's for sure. So we're driven by this scarcity in our marketplace, and we tend to stress our environment as a result to produce what it's barely able to produce. And that's only because we want what we can't have. And this doesn't lend itself to health for our bodies. Profit doesn't care about our health, though. And when we look at these kinds of situations, although we can grow these weird plants up the side of a mountain, we can't change the amount of daylight that those plants are receiving. And so we tend to favor this temperate climate because that's where most of the productivity happens because of the longer days that we're able to have in the summertime. And most of the industrial progress that has occurred in the food industry has typically happened in the temperate climate as well. So if we move down to the maritime effect, the maritime's effect is simply the closer you are to an ocean, the more stable your climate becomes. And this is because oceans have such a large mass of water that the ocean itself can't change temperature with days and nights very readily. And that giant body of water tends to stabilize the climate around it as well. So there's less annual temperature change there, but it will be cooler in the summer and warmer in the winter than in areas that are far away from the ocean. And so that's part of that stabilizing effect, so you don't get the really, really biting winters or the sweltering summers. And it's this maritime effect that is a climate moderator. So, and I'm thinking of Canada, I'm thinking of Vancouver. Can't speak to the eastern coast, but I'm sure it's similar. And it's to your benefit or not to your benefit, depending on how you look at it, I suppose. I personally really like the drastic change of seasons, but it's probably because I was born and raised where there are a drastic change in seasons, which brings us to the next effect, the continental effect. And the continental effect is the exact opposite of the maritime effect. It's how far away from an ocean you are, or a major body of water. And when you are really, really far inland, like Regina, Saskatchewan, Canada, we get extreme temperature changes annually. And so as you get away from an ocean, you're going to have very cold winter temperatures and very hot summer temperatures. So the middle of North America, the middle of Europe, middle of Africa, middle of Russia. This is kind of an interesting thing to take into account when we also look at the altitude as well. So we kind of have to take, very often, we'll have multiple effects that are being combined in a secondary effect kind of fashion, which we also have to apply to our main climate profiles and able to really understand where it is that we're designing and what kind of temperature and weather variations we're going to experience. So an example of the really drastic ranges is the fact that Regina, it varies from minus 40 degrees Celsius to plus 40 degrees Celsius throughout the year. I've actually experienced a 35 degree temperature change in 24 hours before, where I woke up and it was minus 5, and by the end of that day it was plus 30. It's insane. Nobody knows how to dress here for that kind of stuff. But what we plant is affected by this. How we insulate our homes is influenced by what climate we're in as well, which we'll get to in later chapters. So the next secondary effect that we're going to look at here is the rain shadow. So when there's a mountain range in relation to the wind, what can happen is either the wind can get lifted up and over the mountains and then it drops all the rain on the other side, or very often when the wind is bringing that rain towards the mountains, all the rain will drop out so that the area on the other sides of the mountains doesn't receive any. So what you'll see with the rain shadow effect is almost, in a sense, a bit of desertification on one side or another side of that mountain range. And the last secondary effect that we come to is microclimate. So microclimates can, by the name, obviously micro being small, can be a very, very small area in your property. They can be about the size of a house, just depends on how you're setting it up. So a microclimate is simply just a feature in our landscape that might shelter us from cool winds, or it might trap the hot sun. This can give you a warmer region on your landscape. So, for example, right next to a house that's south-facing, you might have a much warmer bed where maybe you might be able to plant plants 1 USDA zone higher than what you normally would plant. So in our case, we can usually plant zone 3 and be pretty confident that it's going to live. But oftentimes, if we can create a really warm microclimate, so next to a huge boulder or right next to the south-facing house, and shelter it from the wind, we might get away with a couple zone 4 plants. And just let me clarify that that's USDA zone 4 plants, not to get confused with permaculture zones that have to do with the distance and frequency of visits. And all of these effects that can affect our climate, they have to be taken into account. So we still will receive our extreme weather events that are unpredictable and rare, but overall, by taking all these things into account, we can definitely recognize the main patterns of our climate and work with that.